Okay, so I'm doing another one. This one's going to be about kind of just, I mean, at first I was going to do this one just about Bayes' rule, particularly relating to problem 3 on homework 7. But then I figured, why don't we just make a whole contingency table from start to finish, because I think a lot of you still kind of struggle with this. So I'm going to go ahead and like make one from the get-go, and it's a little bit of a dumb one, but you know it makes it easy to illustrate. So what I have here is a bunch of A's and B's, and we're going to. It's actually this is the same A's and B's as the zeros and ones from the probability from the tree we just did, or the tree that I just recorded, and I just turned them into A's and B's. What we're going to do here is we're going to make a contingency table that contains. Basically, we're going to look at two character sequences here. So like BA, AB, BB, and AA are the only 4 possible combinations. And we're going to make a contingency table that we can use to create probabilities of, like, for example, what's the probability, the joint probability of, what's the probability of BA out of all the possible combinations? What's the probability of an A being the second character if B is the first? Basically, we're going to be able to do all kinds of stuff, and I'm hoping that I can kind of give you all of this contingency table stuff in one place. So what I did here as a way to kind of visualize our creating of this sequence is I went ahead and I cut a little hole in a piece of paper so that we can use it to just kind of go and look at, say, first 2 characters is BA and then AB. This way you remember always that it's, we're looking at groupings of 2 and then kind of just sliding through the whole sequence. And I'm going to write them on here, and I'm just going to do that quickly for you right now. So our first one is BA, and then the second one is AB, and alright, 15. I hope I did that right, otherwise I'll be remaking this whole video. So anyways, then what we're going to do, notes, we're going to go ahead and draw our contingency table. I'm going to do one right over here. We're going to say here's our 4, and we're not going to do joint probabilities yet. We're just going to fill these cells with what it actually is we're talking about. So. Well, and then we'll do marginals. So let's look at marginal probability first. Right? All right, so if you look what I did here, A2 and B2, A1 and B1, those indicate the, like an A1 would be the first letter as an A, and a B1 would be the first letter as a B, and then A2 is the second letter as an A, and then of course B2 is the second letter is a B, or B sub 2 is what we should say. So that just means that our 4 possible, like there's only 4 combinations of A and B that are 2 letters long, and those are A, B, A, B, B, and A, B, right? We're going to put probabilities in here later, but for now, we're just showing those so that you understand, this is one of the 4 possible combinations. Now, if we count these up, we can say, all right, well, for marginals, we just want to look at how many, let's do this one first. So the marginal probability of the first character being an A is basically just going to be however many there are here that start with A. We don't even care about the second letter right now. So we're going to go, there's 1, there's 2, there's 3, there's 4, there's 5, there's 6, and there's 7. There are 7 occurrences of 2-letter sequences that begin with the letter A. So we're going to put a 7 over here. That's our marginal frequency, right? And then if we know that there's 7 of those, if there's 15, so we know there's going to be 8 that start with B, right? And then for A2, our marginal that we're going to put down here, we want to say, well, how many of these end with A? So let's count them up. That one does end with A. 2 ends with A. 3, 4, 5, 6, 7. Hey, what do you know? Same number. And again, same number here because these always sum to 15. So our marginal probabilities here are 7 that begin with A, 7 that end with A, and 8 that begin with B, and 8 that end with B. And our total is 15. So these should always add up. And let's go ahead and draw that same table, but this time, so that's marginal probabilities. Now I'm going to draw the same one. Instead of labeling the cells with what the pattern is, I'm actually going to put our joint probabilities, because joint probabilities are the ones that go in the cells of the table. So let's go ahead and draw another one and label it joint prob. A sub 2, B sub 2. Alright, so again, our marginals, if we want to draw the marginals in, we'll go ahead and do it, are going to be the same here. 7, 8, 7, 8. But they're not really important because we're not looking at them this time. So joint probabilities, this time what we're going to do is we're going to say, alright, well, how many occurrences of AA are there? And it turns out that we can't actually tell what the joint probabilities are if all we know is marginals. We could guess, we could say, well, maybe it's like 50-50 split, but like we don't actually know. And so until we can actually look at the data, you know, if we didn't gather this information as one big survey, we wouldn't be able to fill this in. But since I've got it all right here, I'm going to go ahead and do it. So this first cell, the AA, so how many AAs are there? There's 1, 2. 2 occurrences of AA, where both the first character is an A and the second character is an A. Okay, and then this one here is going to be AB. There's an AB, 2 ABs, 3, 4, 5. Now, actually, once we know that there is only 2 AAs, we know that there's going to be 5 ABs because the A somethings have to add up to 7 because we know that marginal. So we are actually, if this were a test and you were given that there are 2 here, we automatically know that this one is going to be 7 minus 2 equals 5. But I went ahead and counted them up anyways, just to be old-fashioned and to make sure that I didn't write anything down wrong because I'm terrified that I might do that. Okay. So then for this one, actually, once again, we know that there are 7 AAs, or sorry, there are 7 that end with A. So there are 7 something A's. So if there's two of those accounted for here, this is also going to be 5, right? So now we know what this is, and we didn't even have to count, but I'm going to go ahead and count anyways just to double check. So we want to make sure that this is BA, so there should be 5 of them. There's 1. There's 2, there's 3, there's 4, and there's 5. Perfect. Alright, and then again, by induction, we can say this is going to be a 3, because we know that 8 minus 5 has to equal 3, and this 8 minus 5 has to equal 3. There are 3 BBs in this entire thing. There they are. BB, BB, BB. Alright, so these are joint probabilities. Joint. All 4 of these are they're joint frequencies. I'm sorry. I should have written frequency on both of these. Now, from these frequencies, how do we calculate probability? Well, probability, and a few people are still messing up on this, so I really want to make sure that... actually, I think I'll do that. I'll do a separate video for that.